So have that written down for sure, but let's talk about really how to use that in an example. What does it mean by touches the x-axis, crosses the x-axis? How is the end behavior going to help me with that at all? Let's do that. Am I on example 4?
Yes.
Start off simple. Determine the zeros, multiplicities, end behavior, and graph this function. So let's go through and list it all. And something that's helpful for me when it asks for multiplicities, and even if it doesn't, multiplicities, as you're going to see, is going to be a huge help for graphing polynomial functions. So I would always know your multiplicities. And what I've always done to help you keep your information organized is just make a nice little chart. Zeros and then multiplicities. Just to keep it organized. You don't have to write out a bunch of sentences. So what are the zeros of this function? First of all, is this function already factored?
No.
Yes, it is.
Oh, yeah.
And in this class, later on next week, we're going to learn how to factor something that wasn't already factored. You probably didn't learn how to factor an x to the 4th in intermediate algebra. You're going to in this class. So right now it's already factored. Excellent. So what are my two zeros? 1 and negative 3. Can you guys see that? And again, I'm going to write that as x equals so you guys realize that zeros are x values. Just to keep that in mind so you know that zeros are the x values. And then you're going to look at each one. You're going to identify the multiplicity. So for x equals 1, where did I get x equals 1 from? From this guy right here, right? This is where I got it from. How many times does that factor show up? Twice. Right, we know squared means you write it twice. So since that showed up twice, this multiplicity was 2. Where did I get this 0 from? I got this 0 from the x plus 3, right? How many times did that factor show up?
Once.
Once. So that multiplicity is 1. And then you go back to these 2 bullet points to identify what that really means. If I got an even multiplicity, it means it touches the x-axis. So I'm just going to write here touches so I don't forget. Because even was touches. Odd was crosses the x-axis. And let me show you graphically what that means, because I think graphically is going to be the best explanation for what that means. Go ahead.
You can figure out the shape.
Absolutely, you can figure out everything here. Figure it all out. What did I ask for next? I asked for, oh, you know what, can I also ask for a Y-intercept? No, I'll ask for a Y-intercept in the next. This morning I waited a couple examples. Oh wait, sorry. I don't want to make it too hard for you. Let's do this part. How do I find the end behavior of this function? The first thing I need to know is what the degree is. The second thing I need to know is what the leading coefficient is. So what is the degree of this polynomial function? 3. It is 3. It is 3. What's the leading coefficient?
2.
1. This is a 1 squared times a 1. Those of you who really, I know there's a couple of you in the back who really want to know what it looks like multiplied out. If I did, this would be x minus 1 times x minus 1 times x plus 3. You would multiply that out and you would get x squared minus 2x plus 1 times x plus 3. I did those two first. And then you would end up with an x cubed plus a 3x squared minus a 2x squared minus a 6x plus an x plus a 3, which turned out the degree was 3, the leading coefficient was 1. It was a lot easier to just look at it before multiplying out to figure out what that leading coefficient is, right? You guys now agree with me that I wasn't lying?
So how'd you count it again? I mean, to add it for the degree, just 1?
2 x's,
Yeah.
1 x's. That's a total of 3 x's.
Okay. So you count the individual x.
This is 2 of them.
All right.
Because it's in the parentheses,
Okay, yeah.
yeah. So this is two of them. This is only one of them because there's one up here. Yeah.
So is the leading coefficient always the number within brackets? Like the
It's
negative one?
whatever the number is out here times the number here to the power of 2 times the number here to the power of 1. How about this? The next example, I'll change it so it's not 1. So you can see the
Okay,
difference. How
yeah,
about that?
that's a good
So I
idea.
think the 1 is throwing people off because 1 is too easy.
Yeah.
Okay, so far so good. So end behavior, the degree was 3, the leading coefficient was 1, so that means the degree was odd, the leading coefficient was positive. So what does my end behavior look like? What are the John Travoltas? So it's going to be down to the left, up to the right. So it's my end behavior. You guys okay with that? So then what it also asked for was to graph it. So, and the graph, by the end of this chapter, we're going to learn how to graph this really well and kind of perfectly. But for now, we're going to do a good estimate. Just a good estimate. I'm going to sketch my graph. So there's a few things that you want to plot first. The zeros and the end behavior. What's hard is how do you plot an end behavior? Like I said, this is an estimate. It is not an exact, it is an estimate. I know that it needs to go down to the left and up to the right. So that means somewhere here on the left, it's going to go down. Somewhere here on the right, it's going to go up. I didn't pick a specific point. I just got a good old guess. Down on the left, up on the right. You guys okay with that? And what the zeros are going to do is it's going to help us with that little squiggly. What does it do in the middle? That's what the zeros are going to help us with. Okay. So the zeros, I've got a 0 of x equals 1 and x equals negative 3. So you plot those as your x-intercepts, x equals 1 and x equals negative 3, right? You guys okay with that? So far, so good? Then what do? Now I have to deal with this multiplicities. This multiplicities is what's going to help us connect all of that end behavior and zeros all together. So again, multiplicities, even multiplicity touch the x-axis, odd multiplicity crosses the x-axis, right? So in this case, at x equals 1 it touches, at x equals negative 3 it crosses. Okay, so here's my hint, my personal hint. You can do it multiple ways. My hint is to go left to right. Start with your end behavior all the way on the left side and try to connect all the dots until you get to the end behavior on the right side. If you do that every time, it's just a way of organizing your information. So I'm going to start on the left-hand side. This is my end behavior on the left-hand side, right? So I'm going to start here. And I have to connect the dots. So the first dot I see is that one. So I go to connect it. And then I look. Is this my x value of negative 3? It is, right? So it's my 0 of negative 3. So at negative 3, I had to cross. So instead of going down, I have to cross right through the x-axis. Can you guys see what I mean by cross right through the x-axis? And then I have to somehow make it back to this 0, right? So I don't really know what happens. Something. That's a good estimate. I don't know what happens yet. I'm going to get better later on. I don't know what happens quite yet. And I have to come back down to this stuff. Now that I've touched this 0, I know that at x equals 1, it touches. So what that means by touches is it jumps down and it hits it, but it has to go right back. You see how that one did not cross? Does that make sense? Mm-hmm. This one did cross, that one did not cross. And then you have to connect it to the other side of your end behavior. Ta-da. That's it. Whole kit and caboodle. Okay.
Can you talk about the multiplicity of 2 again?
Absolutely. The multiplicity of 2 means it touches. That multiplicity of 2 happened at x equals 1. So at my x equals 1, I did not cross the axis. I just touched and bounced right back away.
Where'd you get 2 altogether?
Yeah, where's 2? This 2?
Yeah.
Oh, because it showed up twice. This factor showed up twice.
But it doesn't really matter, it's 2, it just matters that it's...
That it's even, yeah. Because it's even, it touches. This fact, where I got x equals 1 came from here.
It shows it twice.
And because that showed up twice, this multiplicity is 2. And because that multiplicity is even, it touches. This one only showed up 1, so that's odd. Because it's odd, it crosses. So this is the even and odd. Multiplicities are even and odd.
So it's nothing to do with the 1 on the x line, it's more, that's just the even number.
Yeah, it's even multiplicity at 1 on the number line. Does that help a little? Should we do another one? Should I do another one where I didn't have so many 1s because that was so boring? We can get used to what those are going to be. Okay, let's do another one. Example 5. Same question. I'm going to do the exact same question. Example 5. Same exact question, and I'm going to do, let's do g of x.
Said you're gonna throw a y value too.
Yes, okay, thank you, I will. I'll do. So let's do same exact question and find the y-intercept. So one more step. Are you guys okay with my laziness in the directions? I apologize. I don't know. I'll type it nicely on it. Okay, so let me do this. And let's do a -2 times, let's do a negative x plus 1 cubed times x plus 3. That's a good one. That's a good one. That's probably a pretty difficult one to find the end behavior of. So that's about probably as hard as I would make to find the end behavior of.
So do we want to start out finding the end behavior or the zeros?
It's a good question. Doesn't really matter too much. I typically, this is what I do. I try to stick with consistency, so I always do zeros, multiplicities, end behavior, the y-intercept, and then I graph last. Yeah, but yeah, if you guys want to do like an order of steps, and you don't have to, there's definitely, this is not required. This is what I tend to do, is I tend to do the zeros, then I do the multiplicities, then I do the end behavior, then I do the y-intercept, and I always tend to graph it last. That's sort of the order that I do it in. And if you guys like steps, some of you guys are step people. Yeah, you totally could have done that in a different order. It's just how I did. Okay, so let's do that. Let's do it all of those. Zeros.
-1.
Why is it not -1? Not to be mean.
So I wasn't sure because negative x.
Yeah, that negative x throws you off, right?
It's going to be a positive if we throw a -1 in there, right?
Right. So what do we want? We want this to equal 0, right? That's what we want. So if I want this to equal 0, what number could I plug in for x to make that equal to 0?
1.
Positive 1, right? Because that would become -1 plus 1. Can you guys see that okay? So it's actually going to be a positive 1. Does that make sense a little bit? That's tricky with that negative x. It is, absolutely. What's another 0?
-3.
-3. Excellent. Any other ones?
+2.
That one doesn't have an x attached to it, so that's not a factor with a 0 in it. You only take the ones that have x's attached to it. Does that help? That's a good point. Yeah, I probably forgot to mention that earlier, but I should. You only take the ones that have x's attached to it. Okay, now the multiplicities. So and this, again, x equals, so I remember that those are x values. So at the x value of 1, what's the multiplicity?
3.
3, because where I got it from showed up 3 times, right? What about at the x value of -3?
1.
Only once, because where I got it from, it showed up once, right? Say -1 here,
Oh, okay.
and that's a -1 to the power of 3.
Stays
And then
-1.
there's a 1 here. You guys see what I did? Which is positive 2.
+2.
Can you guys see where I got that from? I took this number, I took that number and multiplied it, or sorry, took that number, raised it to the power of 3, and then multiplied by that number. Took all the beginning numbers and dealt with them. Which I got you. So really the degree in this case was even, the leading coefficient was positive, so the end behavior was up on both sides. That was that first end behavior.
How did you get the 4 again for the degree?
3 x's, and then plus 1x.
Okay.
It's a lot easier than multiplying it all the way out. So you could, if you really wanted to, you could multiply it all out. I just don't recommend it for you. For your own sake. Keeping your sanity.
Or at least until we get it.
Yeah, sure. But what if I gave you like x plus 3 to the power of 7? I mean, are you really going to write that out 7 times? Like, that's a bad plan. It's just, it's not going to bode well for you. I think life is hard enough as it is. We don't need to think harder. All right, what's the next thing I was asked to find?
The y-intercept.
Right, through with the y-intercept for this problem. So let's do that. Let's find the y-intercept. See how I kind of break up my information, organize it? I did zeros and multiplicities, and I did my end behavior, and now I'm going to do my y-intercept. Keep yourself organized. Don't try to do it all at once. It's not working. Keep yourself organized. So y-intercept, how do I find the y-intercept of anything?
Equal x to 0.
Set x to 0. Perfect. So instead of g of x, you guys all agree that g of x is the same thing as y? I like to call it y because I'm lazy. It's just easier to represent the y-intercept. So So y equals, now I have a negative 2. I have a negative 0 plus 1 to the power of 3 times the 0 plus 3. So this is going to be a negative 2 times, this is a 1 to the power of 3, which is 1. This is a 3. So what do I get? Negative 6? That's what I got. Yes, sir. I'm holding.
Wait, how did you get the positive one?
Yeah, I'm looking positive.
What's negative 0 plus 1?
Negative 1?
Whoa, negative 0
Oh,
plus 1 is 1.
yeah, okay. Stop doing that.
There you go. I like it. Think of it as 1 minus 0.
Oh, that's funny.
Good morning. Yes, sir.
There's no such thing as a negative 0, is there?
Sure there is. It's the same thing as a positive 0. Is 0 a positive number or a negative number?
Just 0.
It's just 0. It's just 0. You could write negative 0. It's just, what it means is minus 0. It's just subtracting 0. It's not mathematically wrong to write that. Okay, sorry. So y-intercept, you write that as 0, negative 6. Right? So now I've got my zeros, my multiplicities, my end behavior, my y-intercepts. Now I'm going to graph. So let's do that.
How would we have graphed it without the y-intercept again?
We just guessed.
We just guessed.
Yeah, like see how
Right, so I was wondering how.
I totally just guessed. That's why we got.
And where are those two plots?
These came from the zeros. I erased them.
Okay.
They came from the zeros. We had a 0 of negative 3 and a 0 of 1. Yeah. Okay, so end behavior. My end behavior was up on both sides. So something like that. Your end behavior, there's no exact for your end behavior. It's a good guess. We're estimating. Yeah. My zeros were x equals 1 and x equals negative 3. That's really boring because that was the same as last time. I'm sorry. 1 and negative 3. That's okay. We got that, right? For both of them, they crossed, right? Keep that in mind. The other, so I did my zeros, I did my end behavior, and now I need to plot my y-intercept. That was the whole point of finding the y-intercept, was plotting that y-intercept. So could I plot 0, negative 6? I think so. 0, negative 6. You know how I plot those points? I plotted the zeros, and then I plotted the y-intercept, and I plotted the end behavior. That's everything I found. Now you connect the dots, and it's easiest if you work left to right. So on the left-hand side, I'm going to start what I've got here with my end behavior. I need to connect that to the first dot I found. And then that dot is at x equals negative 3, right? So at x equals negative 3, did I touch or cross? Cross. So I need to cross right over, right? Just like that. Sound effects are important. What do I do from here? You got to connect this dot too, so somehow this is going to have to go down, right? And then it's going to eventually have to come back up to here. See how I figured out how low down it's going to go now? That's kind of cool, right? And then at 1, now I've hit this dot, so at x equals 1, am I going to touch or cross? Cross. So I'm going to have to cross right over. And then I'm going to have to somehow connect that with my end behavior.
It says it crosses 3 times.
No. The 3, all we cared about was it was an odd number. If it's odd it crosses, it's odd it crosses. We didn't care that it was 3. I cared that 3 is an odd number.
Okay, so that doesn't tell you 3 crosses.
No, it just tells you that it does cross once. Yes?
Tell me how, again, how you got the multiplicity of 1?
This multiplicity of 1? Yeah. So here was my multiplicity of 1, attached to this x value of negative 3. The x value of negative 3 came from here. This factor only showed up once.
Okay.
Okay? Other questions? Ta-da!
So if there was like a number in front of the first negative x right there, so it would be like negative 2x.
Then it would be negative 2 to the power of 3 for my leading coefficient.
So the leading coefficient would change.
Yeah.
So from here we can do domain and range.
Oh, I'm not going to ask you for domain and range for these guys.
Oh, thank God.
I'll ask you for domain probably. Because what's the domain? Maybe I'll do that. I like that you brought that up. I just changed everything. The whole teaching. I am going to ask it. Now I'm going to want to ask you for domain. What's the domain of every single original polynomial function?
Negative infinity to infinity.
So I feel like I can ask that. The range, because technically this actually probably could have gone down lower. We don't know that yet. So I can't ask you for the range for this one.